Okay, so just a review of solving equations, 8th grade. It'll work if you're in ninth grade and you need some help. First thing we looked at was adding and combining like terms. Like terms are terms that have, let's say, if they have an x, or if they're just a constant. We can only add the terms with the same variable to the same power. So here is an x, or 1x plus 3x, and so we'll combine them and we get 4x. And here are two constant terms. We combine those and we get 9. We cannot combine x and 4. They're not like terms. That would be like adding apples and oranges. They're not the same thing. So that should be something that you've seen before, like in 7th grade for sure. Let's see, let's get a better point on that. Let's try that one. Let's get a better point on that. Okay, and we've got a highlighter. Okay, so then what we looked at was the properties. We had the addition property of equality, which meant that we could add the same thing to both sides of an equation and not change the outcome. We had the subtraction property of equality, meant we could subtract the same thing from both sides. We looked at this as though it was a pan balance. So, here's this scale, if you will, and if we add something into one side, we had to add the same something into the other side. Otherwise, the scale would tip. But as long as we put the same thing on both sides, it doesn't tip. Well, equations are the same way. Then we had the multiplication property of equality and the division property of equality. And it's all that same principle. Whatever you do to one side of the equal sign, you have to do to the other side. And when we say sides, we mean everything on the side of an equal sign. So here's an equation that's solved. And if we look, we've got a variable term, a variable term, a variable term, and then we've got a constant. So we would solve this by adding up all of those variable terms. So we'd have 1c plus 2c plus 2c. We'd end up with 5c plus 10 equals 230. Then we would have to use the subtraction property of equality, which says that we can subtract the same amount from both sides of that equal sign without changing anything. So 5c plus 10 and then minus 10 just leaves the 5c there. And that's in fact why we did it. And then equals 220. And then we're going to use finally the division property of equality, because that 5, even though it doesn't say anything, because it's just touching that c, that's a multiplication. So 5 times c equals 220. So we divide both sides by 5 because that will cancel this 5 out. And that will just leave c over here. 5 divided by 5 is 1. 1 times c is c. And 220 divided by 5 is 44. Okay, and that's how we're going to solve equations. So let's look at a couple. Let's look at a couple here. So if we start with number 3, I'm going to combine the like terms that are on the same side of the equal sign. Let's make that clear. They're on the same side of the equal sign, so I can combine them. So 4x's plus 7x's, and here's what we're doing when we do this. We're adding the 4 and the 3 and putting the x there. Now that's a step, as long as you know that's what you're doing, you don't need to write that step. So 4x's plus 3x's is 7x's minus 1, and it still equals 6. Now we're going to undo minus 1. These are inverse operations that we're doing. In other words, they undo what's there. We're trying to take this apart, so when we're done, it just says x equals something. So we have to undo, starting with the minus 1 by plus 1, both sides. Once we've done that, we have 7x left over here. And over on the other side, we have 7 left. Now we're going to undo the 7 times x. We undo multiplication with division. Division is the inverse of multiplication. So 7 divided by 7, that's just 1. That's why we did this, to make that turn into 1x. Which is the same as x. And then on the other side, 7 divided by 7 is also 1. And there's the answer. Now, if we wanted to prove that that's the answer, we could go back up here and we could put in 1 everywhere there's an x. Four times 1 plus 3 times 1 minus 1 equals 6. 4 plus 3, 7, minus 1 equals 6. 6 equals 6. And that would verify that that's our answer. Let's try another one. Negative x, 10 equals negative x plus 3x plus 4. So I start with my like terms. Negative x plus 3x is positive 2x plus 4. I'm going to draw the line under the equal sign again. That's the way the kids used to do it in 7th grade when they were solving equations. Okay, so now I want to subtract that 4. I want to undo plus 4. I undo plus 4 with minus 4 on both sides. I can't just do it to one side of the equal sign. I have to do it to both, otherwise it tips the out of balance equation. So if I do this correctly, I get 6 equals 2x. Now, last step, 2x is 2 times x. I want to get x to be alone, just to be 1x. So I undo that multiplication by 2 by dividing by 2 on both sides of the equal sign. Then I have 1x. 6 over 2 is 3. 3 equals x. And again, I could verify that. 10 equals negative 3 plus 3 times 3 plus 4. Negative 3 plus 9 plus 4. 6 plus 4. 10. Does 10 equal 10? Yes, it does. So that must be the right answer. Oops, that was supposed to be x. Okay, so now I'm going to go to the next lesson that we did together. D. This was where we were clearing fractions. And again, it's just an inverse operation. It's just an inverse operation. Here, we can see that that 4 is dividing both sides of the equal sign. I'm going to rewrite the whole thing just the way it is. X minus 1 divided by 4 equals 6. The way I undo divided by 4 is timesing by 4. This 4 up here is not in the denominator where that one is. Imagine if it was 4 over 1. Okay? And then I have to times by 4 on the other side of the equal sign as well. When I do that, this 4 being in the denominator and this 4 being in the numerator cancel each other out. 4 over 4. Here, let me go back a step or two. Let me do this another way. Let me rewrite this now as 4 times x minus 1 over 4. And I'm only doing this to help you visually. This is not needed in your work. Okay? And 6 times 4 is 24. But if it helps you, do it. If it helps you, do it. There's nothing wrong with showing an extra step. Me, I would just cancel it back up here where I'm doing in green. I would have just did that. But if it helps you to visualize why it cancels, then rewrite it in the numerator. And it's timesing the entire numerator. That's why it gets to cancel. So I get, whoops, still in green. So I get x minus 1, and I get 24. And then I'm going to just add 1 to both sides. And I have x alone, and it equals 25. If I wanted to prove that's my answer, 25 minus 1 over 4. That's 24 over 4. That's 6. That proved it. It makes it a true statement. Okay, so again, we're undoing division. We're clearing the fractions. That's actually the name of this process. It's called clearing the fractions. All those times we complained about fractions, now we don't have to have them anymore. So we begin by finding the least common denominator. In this one, the least common denominator is 4. So I multiply both sides of the equal sign by 4. So I have 4x over 2 plus 4 times 1 over 4. That is a times there. Equals 7 times 4 over 4. Now I start my canceling process. There's 1 2 there. There's 2 2's there. There's 1 4 there. There's 1 4 there. There's 1 4 there. There's 1 4 there. They cancel. In other words, 4 over 4 is 1. 4 over 4 is just 1. 4 over 2 is 2. That's where that 2 came from. So here we have 2x, the result of that, plus here we have 1 equals 7. Now I add 1, or I subtract 1, pardon me, subtract 1 from both sides, leaving 2x equals 6. Divide both sides by 2. See, this is just the inverse of clearing the fraction. We're clearing the multiplication now. That becomes 1. X equals 3. In the next one, clear the fraction by multiplying both sides by 3. So I'm going to multiply this side times 3. And I'm going to multiply this side times 3. The reason I'm doing 3 is because I want to clear the 1/3. 3 times 1/3 is just 1. We don't write that down. We just know that. We know that 3 times 1/3 is 1. It's 8th grade now. And I mean, I hope you all know that, because it would be just way too much to write if we had to write 3 times 1/3 up here, 3 over 1 times 1 over 3, and do that math. We would forget what question we were solving before we finished. So we just know 3 times 1/3 is 1. That makes that go away, leaving the 2x minus 4. Over here, negative 6 times 3 is negative 18. Now we undo minus 4 with plus 4 on both sides again. 2x 2x is left, and here we have minus 14, or negative 14. And finally, we're going to undo the 2 times x by dividing by 2 on both sides. So now we have x equals negative 7. Here's another one where we can clear the fraction. Now, if you're in my 8th grade class, you should recognize these. They are in your booklet. These are all questions that we did together and that you had homework to do. So, first step, I'm just going to write it again so that it's bigger so you can see it. This is not necessarily the first step. This way, you'll see more clearly what I'm doing. At least I hope you will. So, now, there's a divided by 3. This whole side of the equal sign, here is divided by 3. So, what I'm going to do is I'm going to undo divided by 3 by timesing by 3. So, and remember, this 3 is dividing. This 3 here is timesing. It's in the numerator with that negative 2x minus 5. That's why these cancel. That's why that happens. Do you need to rewrite it showing it in the numerator? If so, feel free to do it. But this is what's going on here. And I've had at least one student struggles with this idea of why these 3's cancel. Because that 3 I'm multiplying by is in the numerator. It's in the numerator. The other one's in the denominator. They undo each other. 3 over 3 is just 1. 1 times negative 2x plus or minus 5 is negative 2x minus 5. And then on the other side, we have 9. Now we're going to undo this minus 5. Any ideas? Yes, plus 5. Both sides. And these are just the rules of algebra. It's like if it was a game, this is how you play the game. Now, finally, the next step is to divide by that negative 2. Undo that multiplication by negative 2 by dividing by negative 2. And that just leaves us with x equals negative 7. Okay, I hope that this helped. We also did word problems, but I'm not going to review those in this video. I want you to just focus on these steps. Undoing multiplication with division. Undoing division with multiplication. Undoing subtraction with addition. Undoing addition with subtraction. And we're basically taking the equation apart to get the x alone. Okay, so now getting to using the distributive property with all of those other steps. So the distributive property distributes a multiplication, and you'll know it because you'll see a number just outside the parentheses, just kind of just touching. And that indicates that there is multiplication going on here by -2. Sometimes it'll just say minus. We'll find an example like that, but I don't think we'll see one right here. Okay, so what we're going to do is we're going to distribute that -2. Where did it go? Okay, we went all the way back to the beginning problems. And here we go, -2, there it is. So -2 is multiplying times the x and times the 1. And in this case, since it's plus, it's a positive 1. We would say that this is the distributive property of multiplication over addition, because there's an addition there. So -2 times x plus -2 times 1. Now this is a step that I wouldn't have written, except that I'm showing it for the first time. I would have just done the multiplication. So -2 times x is -2x plus -2 times 1 is -2. So I could write plus -2, but I'm trying to simplify. This is the process called simplifying it to solve it. And so instead of having plus and negative, I'll just write -2. It's the same thing. So now I have -2x minus 2 equals 8. I'm going to undo the -2 by adding 2. And then I'll have -2x equals 10. I'm going to undo the -2 times x by dividing by -2 on both sides. And then I'm finished. And you can pause the video if you need to look at that further. I'm going to go right on to the next one. Now we have the distributive property of multiplication over subtraction, because there's a subtraction sign in here in the parentheses. So -3 times x is -3x. -3 times -4 or -4. I'll write the step. We're going to have minus -3 times 4. That's -12. Minus, the minus and negative. This is why I didn't want to write that, because that can look confusing. So let's just do what it is. -3 times x. -3 times -4. Those two negatives turn into a positive. 3 times 4. And over here, there was still 13. So, like terms now need to be combined. So I have -3x plus 12 minus 8. That leaves 4. And over here, I have 13. Now I'm going to undo that plus 4 with a -4. Subtract 4 from both sides of the equal sign. 13 minus 4 is 9. -3x plus 4 and -4 is just -3x. The last step now is to undo that multiply by -3. -3 divided by -3 cancels. It's just 1 times x. So just x. And 9 divided by -3 is -3. So we could leave it -3 equals x. I would prefer to rewrite it with the x on the left-hand side. It's okay if you don't. But one day you may want to neaten everything up, keep it all orderly, all looking the same, and always have the variable equals. I'm going to go down to number 9. Number 9, I could clear the fraction as we did in the last set. If I did, I would multiply both sides by 2, and that would result in 2t plus 4 equals negative 16. See, multiplying by 2 to clear the 1/2. That cleared that. That's why this is left right here. That cleared that. And then 2 times the negative 8 is negative 16. But in this case, I notice that it's an easy multiplication to do. If I just distribute this multiplication, it's an easy one to do. 1/2 of 2t. 1/2 times 2t is 1t. 1/2 times 2t is 1t. Plus 1/2 times 4 is 2. And so here are the two equations I could result in, depending which way I did it. Now I'm just going to simply subtract that 2 from both sides. And I will have t equals negative 10. Now over here, I might have one more step. I'm going to subtract 4 from both sides. And I get 2t equals negative 20. And then I'm going to divide both sides by 2. See, there's that extra step. T equals negative 10. Of course, we get the same answer because it's the same problem, and we didn't use a bad rule. We used good rules. Sometimes you have to see the step ahead to know the shorter path. But is it wrong? Is either one of those wrong? No. They both followed the rules of algebra, and they both got to the correct end. So that's what's important. So here we go. I want to find one with just a minus with no number there. There it is, number 20. Notice how there's just a subtraction sign outside of the parentheses there. Okay, we can distribute that. That means we have to negate everything inside. So this becomes negative x, and instead of minus 5, it would become minus negative 5, which is the same as plus 5, right? Two negatives turn to a positive. Negative 5 or minus negative 5. It's the same as plus 5. Excuse me. Okay, so now we're going to combine the like terms. We have x and x, and we have 5 and 2. So negative x minus x is negative 2x. 5 plus 2 is 7. So we're going to undo plus 7 with minus 7. Negative 2x equals negative 4. And finally, we undo times by negative 2. That's what that negative 2 is doing. We undo it with divide by negative 2. And we get x alone, x equals 2. All right, well, thank you, and I hope this helps.